I'm Weston Callow. You've seen me in such fine quality, epic chemistry educational videos as Le Chateliers Principles and what does equilibrium have to do with some French guy? Today we're going to be looking at Le Chateliers Principle. Now it's in the realm of equilibrium that's happening with chemistry reactions. And we're looking at what happens to a chemical reaction when it comes at an equilibrium where essentially the rate of products and reactants going back and forth, that's the idea behind the equilibrium, that it's going at a steady pace, okay? And what happens when you change something in the chemical reaction, like adding heat or taking away heat, or adding reactants, taking away reactants, or what happens if you remove product or you add extra product? Now, Henri Le Chatelier was a French chemist, and what he was basically saying was, if you got a shift in a chemical reaction, then it will naturally correct itself, which would make sense for a lot of things. So the idea behind this video is looking at a chemical reaction where we have nitrogen plus hydrogen and we get ourselves ammonia and we get a little bit of extra energy out of it, 22 kilocalories, that's what kcal stands for. And which way is the reaction going to shift? Where's the equilibrium going to shift? Because the idea is that if the equilibrium is going like this, okay, what's going to happen as I whip my head back and forth, I whip my head back and forth to the equilibrium when you change something. So let's go ahead and we're going to shift here, so to speak. Let me bring this down a little bit. Okay, so here's our reaction. We have N2 and 3H2 and 2H3, and we get some energy out of it. Now what happens, and this is where we get the stress. And the stress, some people look upon that as a negative thing. In life, you will have stress. You just will. Otherwise, if you had no stress whatsoever, you wouldn't even get out of bed in the morning. Okay, you still have to brush your teeth. You still have to do all those things. And you could make the argument that it's stress. But hey, so's a chemistry exam, yo. That's stress. Right. Although I would tend to think something is more stressful if somebody is trying to, I don't know, hurt you. That probably would be a little bit more stressful. Just saying. Okay, so here's our reaction, and let's go ahead. We're going to add more reactant. We're going to add more nitrogen. What's going to happen with the equilibrium? Well, the equilibrium is going to shift to the right. And you'd say, wait, I'm not understanding. Let me get a meter stick. And that might possibly help you on this. Because remember, it's a balance. If we look at an equilibrium as a balance. So for this side here, ladies and gentlemen, you're going to have your reactants. And then on this side here, you're going to have your products. So the idea is, as long as this meter stick is nice and horizontal, the equation, the chemical reaction is an equilibrium. Now if I add more reactant to it, like nitrogen for example, what happened? I put stress on the equilibrium. I put stress on the system. Now Henri Le Chatelier said it's going to fix itself. Now it's going to fix itself in one of two ways. Okay? Well, there's only three possibilities if you put stress on something. One is that the reaction will shift to the right. The other is the reaction that it will shift to the left. Or there's no shift. And we're going to see that. So we're adding a bunch of reactant here. We're adding a bunch of N2, and notice how all of a sudden, oh my gosh, we are no longer in equilibrium because we have all this extra reactant. Okay, now this also applies to hydrogen gas as well. So we're going to look at nitrogen gas here for a moment. And what we're finding is the equilibrium is out of whack. Henri Le Chatelier said it's going to shift. It's going to shift to bring itself back up like this at equilibrium. But if it's out of whack like this, which way is the equilibrium going to shift? It's going to shift to the right. Well, what do we mean that it's going to shift to the right? Well, if it's out of whack like this, then that means you've got a whole bunch of reactant here. More product needs to be made in order to bring this equilibrium back to normal. Okay, so that means all of a sudden now the reaction is going to speed up this way. It's going to put more. So then we're going to have more ammonia made on this side, and now we're back at equilibrium. Things go back to normal. So when we look at something like this, adding N2, it's going to shift to the right. Okay, what about the concentration of the hydrogen gas? Well, that's going to go down, isn't it? Why? Because it's being used up faster because we have extra N2 gas. All right, so it's going to decrease. The concentration of the H2 is going to decrease. Now, what's going to be the concentration of our product? Well, the concentration of our product, in fact, is going to increase because now we got more ammonia being made because we're trying to reset that equilibrium, which was like this a moment ago with all this extra reactant, and now we're going to shift it that it's nice at equilibrium, but we're going to have more product as a result, and we go back to an equilibrium as it should be. Now, what about the equilibrium constant K? Well, in this case, it's staying the same because the equilibrium is staying the same. So that's what we've got, ladies and gentlemen. So now let's go ahead and let's take a look what happens if we add H2, hydrogen gas. Which way is the equilibrium going to shift? Is it going to shift to the left, to the right, or is there going to be no change? Well, guess what? If it's shifting, if you're adding more reactant, look what happened to your equilibrium. How are you going to get it back to equilibrium? And again, Le Chatelier said it's going to shift either to the left, to the right, or do nothing to fix itself. Well, it's going to do something, so nothing isn't a choice. If it shifts to the left, now you've made even more reactants, and that kind of messes up that equilibrium. So the only choice you have is going to shift to the right, which means more ammonia is going to be made. So the reaction is going to shift to the right, okay, and what's going to happen to the concentration of the nitrogen? Well, guess what? If you've added more hydrogen, the reaction is going to shift to the right. That means the concentration of our hydrogen is going to go down as well. Okay, well, what happens to the concentration of the ammonia? You're making more of it, and if you're making more, guess what? It goes up. Woo. Now, what about K? What about our equilibrium K? Well, guess what? You made an adjustment. The equilibrium is adjusted, and guess what? It is still the same. Okay? Now, let's take a look at another one. Why don't we go ahead and let's add NH3. So all of a sudden now, ladies and gentlemen, we are going to be adding a whole bunch of product. Whereas we added a bunch of reactant here, now we're going to add a bunch of product. Oh, we are out of equilibrium. If you can tell here, oh my gosh, what are we going to do? This is a crisis. What is the shifting going to do? What is Le Chatelier going to say? Well, it's either going to do nothing, which that's so not happening, or it's going to shift to the left or shift to the right. Okay? Well, if it shifts to the right, guess what? That means more NH3 is made. Oh my goodness, that equilibrium is even more out of whack. It's almost like the federal budget. No, so that's not happening. So what's going to happen? The only option it has is that all this extra ammonia that's on this side is going to break down faster, okay, and create more nitrogen and more hydrogen gas in order to bring back that equilibrium at that horizontal point. So if we add NH3, the reaction is going to shift to the left. What's going to happen? What's going to happen to the concentration of our N2 and H2? Well, if the ammonia is breaking down, we would expect these to go up. You're breaking down the product, so now you're building up the reactants. Now, what in the world's going to happen with the K? Well, the K is going to still be the same. Okay? Now, what happens, we're going to do another situation where what happens if we have to remove something. We've added stuff. Now, let's take away and see what happens. What's the worst that's going to happen? The end of the world? No, I don't think so. God gets to determine that one. Okay, so what happens if we remove N2? Well, if we're taking N2 all of a sudden, what's going to happen? Well, things are not going great, are they? If it's reacting, then that means we've got more product than reactant, right? That's what's happening. If we're taking the N2, okay, it's shifting. We're not in equilibrium anymore. We can't, something's got to happen. And according to Le Chatelier, ladies and gentlemen, it's going to shift to the left. Okay, it's going to shift to the left. All right, and into there is no change. Now, what's going to happen? What's going to happen to the hydrogen gas concentration? Well, if it's going to shift to the left, then that means that's going to increase. There's going to be more hydrogen gas available as a result, because that means that the ammonia is going to be breaking down. Okay, that's the general idea. And what happens to the NH3? Well, it's being broken down. Guess what? That's going to go down too. That's going to decrease because of that. And what happens to the equilibrium K? No change. No change whatsoever. And you know what? You're going to get the same thing when you remove the H2. Okay? You're going to get that same shift. You're going to have an increase in the nitrogen because our ammonia is breaking down rapidly. So if it's breaking down, it's going to break down into hydrogen and nitrogen. And guess what? We're taking away the hydrogen. Okay? But that means there's going to be more nitrogen coming in. Okay? So that's going to increase as it goes. Now, of course, what in the world is going to happen with the K? The K, guess what? It's going to stay the same. Yeah, absolutely. Okay. Hey, I'm hoping that this video is helping you guys out. Now, we still have a few more scenarios to look at, but I am going to do the remove NH3. Okay, so now we're taking away the NH3. Here we go, we're back at equilibrium. NH3 is our product. If we're removing the product, guess what? Now we have a shift, right? If we're lifting the product, we're changing the equilibrium. Now we're here. Le Chatelier says, do nothing, go to the left or go to the right. Well, what's going to happen here? We're going to shift toward making more product, right? Because all of a sudden now you have all this nitrogen and hydrogen. They're saying, holy cow, we got to go make more ammonia now, 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 now. And what happens is we increase in making ammonia and we bring it back to that equilibrium. So guess what? What happens to the remove the ammonia? The reaction's going to shift to the right. Okay? Because now more ammonia's got to be made. We got to replace what's there. Okay? The hydrogen and the nitrogen are going to decrease. Why? Because they're being used up. They're being used up to make that replacement ammonia. We got to get that equilibrium back. That's the only way we can do it. I got my classroom door open, so it kind of echoes into the hallway a little bit. Okay? All right. Now what happens with the K? The K, guess what? Is going to still be the same. Woo! Can you imagine that, ladies and gentlemen? All right. Now, so far we've looked at, ladies and gentlemen, what in the world happens when you have altered the amount of product and the amount of reactant. But what happens when we change some other factors? What happens if we mess around with the pressure and the temperature? Because that certainly would be a factor involved in any equilibrium, because that's reality. Those things do happen in chemistry. Okay, so what happens if you increase the temperature? If you increase the temperature, now you've added more stuff. And you'd have to look at the original equation here. If you increase the temperature, guess what? You've added more heat to your reaction. And guess what? If you've added more heat, now you get all that heat here. Guess what? It is now, here was an equilibrium, we add the temperature, we've altered the equilibrium again. So what did Le Chatelier say? It's either going to shift to the left, the right, or do nothing. And guess what? Do nothing isn't a choice. So we're going to have to shift to the right. So that means ammonia, because of that extra heat that's there, the ammonia is going to need to break down in order to compensate, in order to make up for this side not having enough to keep it at that equilibrium. Okay, so we're going to go and, oops, let's bring this in. So if we increase the temperature, we're going to go to the left. Okay, it's going to shift to the left, and what's going to happen? Well, the concentration of our ammonia and hydrogen are going to go up, because now we're breaking down this ammonia rapidly, rápido, muévete, muévete, ándale, 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 break down that ammonia, and now we got more nitrogen and more hydrogen. The concentrations of both have gone up. Not exponentially, but they definitely have gone up. Okay, so what happens to the concentration of the NH3? Oh, well, hey, it decreased. It decreased as a result. What about the equilibrium? Does the equilibrium get affected? You bet you did. It sure does, because our equilibrium value is going to have to, it's got to go up or down. And when you're dealing with kicking up the temperature in this case, it's actually going down. That's pretty much it. Now, what happens if you decrease the temperature? Well, if you decrease the temperature, think about it. You're removing that heat from the product side, right? You know that 22 kcal just a moment ago there? If you're removing it, guess what? You've altered what it is. You've altered it, and now the reaction is going to shift to the right. Well, wait a minute. If it's shifting to the right, what's going to happen to the concentrations of the ammonia? If it's shifting to the right, that means the ammonia concentration is going to go up. Because we need now more. We got to have more. We got to make more. We got to make more. We got to get that equilibrium back at the horizontal level. Okay? Well, what's going to happen here with the nitrogen and hydrogen? Guess what? It's going to go down. It's going to go down faster than some celebrity's popularity when they go blow it in the mainstream media. Okay. So now you guys got that idea. What in the world's going to happen to the equilibrium? Well, the equilibrium, because you decrease the temperature, okay, it's going to go up. The K value will go up as a result. Okay? Now, what about pressure? Pressure is an interesting one, because part of the idea about pressure is also dealing with the number of moles of gas that you've got in your basic equation. Okay, so the idea about that, ladies and gentlemen, it has to do with the number of moles of gas that you have. If you have essentially 1 mole of gas on each side of the equation, the pressure isn't going to do a whole lot. There isn't going to be a lot of excitement. But on the other hand, if you increase the pressure, okay, the reaction is going to shift to the right, okay? And if the reaction shifts to the right, guess what? The ammonia is going to go up. All right, it's going to go and favor, when you're increasing the pressure, it's going to favor making the smaller number of moles of gas. That's the idea behind it. So that's why it's going to shift to the right, because if you look at the number of moles of gas, ladies and gentlemen, I got to hurry up. If you look at the number of moles of gas here, I've got 1, 2 to 1. Never mind the coefficients. It's 1, 2, 2 to 1. Okay, so we got to go work with that. So guess what? Those are going to go down. Okay, and what happens to the equilibrium? The equilibrium's, it's equal, it's the same. And guess what? It's going to be the same down here as well. When you decrease the pressure, if you decrease the pressure, guess what? The larger number of moles of particles are going to be favored as a result, and it's going to go to the left. As it goes to the left, guess what? If it goes to the left, the ammonia and the hydrogen are going to go up in concentration, and the overall concentration of the ammonia goes down. Hey guys, I'm hoping this helps you out a bit more with the Le Chatelier equilibrium. This is a very important principle, and keep in mind, Le Chatelier, do nothing, shift to the left or shift to the right. That's the bottom line. Okay, I'm Weston Callow, and I approve of this video. Take care.